Hello, everybody. So this is the video where I am going to go over the process to simplify radical expressions. Now, you see here on the PDF, this is section 19, but in our course, I am calling this section 7.3. Okay, so let me go back here and again give you an idea of radicals. Okay, before you even look at this particular rule. So in class, we discuss radicals, and a radical or a radical expression is an expression that involves this symbol, which is called the radical, and you will have some information inside the radical. For example, let's say 4x squared y. The expression inside the radical is called the radicand. And in here, outside of the radical, there may be a number, 3, for example. And this number is called the index. So all of this I mentioned in section 7.1. Okay, as a note, I mentioned before that if the index doesn't appear, does not, or maybe is not visible, maybe that's better. If the index is not visible or present, not visible, it means the value is 2. Okay, for example, square root of 16. You don't see the index here, which means the default is 2. So we know from the definition what a square root is, right? 4, because 4 times 4 is 16. We also know what a cubic root is. In this case, it's 3, because 3 times 3 times 3 is 27. So this is the basic definition. We know that. Now, what we need to do, as we did over here in these two cases, this is the process of simplification. We need to be able to simplify. But what happens when we have something like this, for example? Square root of 50. So this is what we need to discuss right now. So if we look at this section, simplifying radicals, one thing that we can do, as you can see here, that if we have a single number in here inside the radical, we may have to break it in two so that one of the two radicals is simplifiable and the other is going to stay the same as before. So this is the example with the radical 72 right here. So take a look. I went over this problem in class. I will go over it here again, briefly. So the 72, we cannot take the square root because this is not a perfect square. In other words, I cannot find two numbers that multiplied together will give me 72. So what do? Well, we divide this by 2 and we get 36 times 2. And then we realize that 36, I can take the square root. So we break it into two pieces, 3 radical 36 and radical 2. The square root of 36, I know it's 6. And then it multiplies the 3. And then it multiplies the radical 2. So the radical 2, square root of 2, remains as radical 2 throughout the process because I cannot simplify. This is what we call an irrational number. So the final answer for this problem is 18 radical 2. So the same has to be done in this case with the radical 50. I cannot find two numbers, just like I did with 16, such that this number times that number equals 50. And these are identical numbers. Okay, the closest I can get is 7. 7 times 7 is 49. If I go to 8, I get to 64. So it's not 7, it's not 8. So what do I do? Well, I'm going to have to apply their rule. I am going to break this into two numbers, one of which is something I can simplify. 2 times 25 is 50. And then you might think, well, why not do 5 times 10? 5 times 10 is 50. Yes, that's right. But I cannot simplify this, and I cannot simplify that. So this product is not useful, but this is. Now I will break into radical 2, radical 25. Cannot do anything here, but this I know is 5. So I have radical 2 times 5. And as your final answer, you always leave the radical last. So you're going to write this last, and you're going to write this first. So here is the final answer for this problem right here. So this is what we have to do in this section. Okay, so this is called simplification. A little bit more advanced simplification from the ones we saw in the first section. So let's take a look. Similarly here, the fact that you have a minus here doesn't bother us because we will break this into -8 and 4, right? And we know from doing this before that cubic root of -8 is -2. And this stays the same because I cannot simplify the cubic root of 4. All right, we'll discuss this in a minute, because this is the other type of simplification that we're interested in, where we may have a number and variables inside the radical. So we'll talk about this in a minute. Let's do some of these problems so that you can see how to work them out. So I am going to do possibly 2, this one, and maybe this one, and leave you the other 2 for practice. Okay, so let's do radical 75. Okay, so here we go, radical 75. Just as before, I cannot find a single number that gives me 75, right? So for example, if I try 8 times 8, that's 64. If I try 9 times 9 is 81. 75 is in the middle. So this doesn't work, that doesn't work. So what do? Well, I have to break this number. Well, so how do I break this number? Well, I'm going to have to see if I can break it so that this times this is 75, but one of these two numbers is going to be a number where I can take the square root, right? Remember, you don't see an index, the default is 2. And in this case, I can break it as 3 and 25. Okay, so 3 times 25 is 75, you can check. And now I know that I can simplify square root of 25. So I'm going to break this as radical 3, radical 25. I know this is 5. And I cannot simplify this further. 5 radical 3. So that's the answer for that problem. Okay. And remember, right? We want to break this number so that one of the two numbers as a product is a number that I can take the square root of in this case. Okay, so let's take a look at the other problem. So let's do -5 radical 27. So -5 radical 27. Cannot break this number, cannot take the square root of this number. right? And you can try. You can try 5 times 5 is 25. That doesn't work. And 6 times 6 is 36. So neither of these two work. So that means I have to break this somehow. And I already know how to break it. So 3 times 9. 3 times 9 is 27. And this is what we call a perfect square. I can take the square root of this. So this is going to be -5 and radical 3 times radical 9. Nothing I can do with the radical 3, but this becomes 3. So -5 radical 3 times 3. So these two now get multiplied. -15. And the radical 3 gets attached. Remember to leave always the radical as your last part of the expression. Okay. All right, so let's take a look and let's do one more. Maybe we'll do this one last. 48, 8 to the 4th. Fourth root, 48, 8 to the 4th. So fourth root, 48, 8 to the 4th. So let me make sure that I copy this thing correctly. Fourth root, 48, 8 to the 4th. Okay. Okay, great. So now this is a fourth root. Possibly we might not see this too often, but I am going to break this immediately. I don't really know how to do this. So I am going to break it immediately. And I will handle each one separately. This one I already know, right? So we know the technique I told you in class, that you are to get this number and divide by the index. So this is going to be a 4 over 4, a to the 1, or just a. So this is a, this is pretty straightforward. Now, the fourth root of 48, I would need a number, right, that multiply by itself 4 times, it's 48. Okay. So if you think about 2, for example, this is 2 times 2, 4. 4 times 4 is 16. If you think about 3, this is already 81. So it's neither 2 nor 3. So I have to break this number. Okay, and I can think of it as maybe if I do, how about 3 and 16? So there's nothing I can do with the 3, but how about the fourth root of 16? This is actually 2. Why? 2 times 2 times 2 times 2 is equal to 16. So this is correct. So now I will rewrite this as fourth root of 16, fourth root of 3 times a. This I already know to be 2. It's going to multiply the a, and the fourth root of 3 stays. All right. So you might think, well, Professor, how in the world am I going to know that this has to be broken into 3 times 16? Okay, why not 4 times 12? 4 times 12 is 48, but this won't help me. Be very careful. The fourth root of 4 is not 1. Okay. So you can try. So my experience tells me that 48 has to be broken this way. But don't worry so much, because it's unlikely that we're going to give you fourth roots. Much more likely that we're going to give you square roots and cubic roots. Okay, but this is the process of simplification. Sometimes you have to try a little in order to find the pair that you want. Okay, the second type of simplification that we have to do in this section is this kind, where we have possible multiple variables here. And as this example shows, a number. The number we already know how to do. So let's take a look in this case. We cannot take the square root of 18. So we break 18 into 9 times 2. We obviously can take the square root of 9. And then I am going to show you now how to handle the variables inside. Okay, because the main technique here is to make this number divisible by the index of the radical. And I'm going to show you exactly how to do it here. Okay, it's going to be similar to this problem where I have a to the 4th p7, but this is the cubic root. So I have to break the variables so that instead of having a to the 4th, I am going to have a to the 3rd because it's divisible by 3 and some leftover. Same thing with the 7th. I have to break this into something that is divisible by 3 and a leftover. This is exactly what the authors did over here. So these two get simplified by dividing their respective exponents by the index, and the leftover remains untouched. Okay, so let me go over the examples, a couple of examples with you. I only have 2 examples here, so I can do both. So let's do this first one, 50x8y9. So these all are going to be labeled simplified, okay? All right, so let's check exactly what the problem was. 50x8y9. 50x8y9. And if you want, you can immediately do this. This is perfectly fine. This is a square root because you don't see the index. You can break it into 3 pieces. It goes very fast this way. This one you already know. You're going to break it into 25 times 2. Okay. The 25, you know that it simplifies to 5. And this remains under the radical, just as before. So I can immediately go ahead and write this already here. Times, right? The multiplication continues. The x8 under the radical will follow the procedure mentioned in class, that this number here will get divided by the index. And you don't see it, but it's 2. So it's going to be x to the 8 over 2, which is x to the 4. So here is your x to the 4. Okay, this is also not new. This is from section 7.1, 7.2. This is new. So let's take a look at this. I cannot divide the 9 by 2 because the division must be a complete division with no remainder. So how do I do this? Well, we are going to break y9 into y8 times y to the 1. And if you remember from the properties of exponents, when we have this on the right, when we have this, right, what we do is we add the exponents. So y8 times y to the 1 is y to the 9. So that's correct. And the reason we want this way is because of the following now. Now, once I break these two, I can simplify this the same way I simplified x to the 8. The 8 gets divided by 2, and I end up with y4. And this is my leftover. I cannot simplify this further. So here I will write y to the 4, y. And my final answer is this. I'm just going to have to rewrite it in the proper format. So 5 goes first, x4, y4, and inside the radical, this and this. And you don't write two radicals, you're just going to write a single one, 2y. So that is the answer for this particular problem. Okay, so this is, I would say, this is a typical problem that you might see on a homework, and especially on an exam. Something with a number and possible multiple variable that you have to do this kind of simplification to get the final answer. Okay, so let's do one more. We can do the last one. So let's do the last one, which is cubic root minus 16 cubic root minus 16 let's make sure that we copy this thing correctly. M5 and 3. M5 and 3. Immediately, you can break it into 3 parts if you want. Cubic minus 16 times cubic M5 times cubic and 3. And notice that this is, again, straightforward. 3 divided by 3 is 1, so this is just n. The minus 16, I cannot find a number for the cubic, but I can certainly break it as -2 times 8. Actually, be careful here. -8 times 2, and here's the cubic. And the reason I need a -8 is because I cannot have the minus left over in here, since I can remove it. The cubic of -8 I know, and the cubic of 2 I cannot simplify. So this is -2, and this stays the same. So we couldn't do the -16. It's the same process as I showed you before. You can try to find numbers, and let me just do it here, just to illustrate the point. If you try -2 times -2 times -2, that's -8. That's too low. If you try -3, that will give you -27. That's already beyond the -16. So neither of these two work. So when that happens, you will have to break it as I broke it over there in the corner. Okay, so this is already the answer for that. So -2 cubic. Do not forget to put the index, because that would be a mistake. And now I have to handle these. So this part we knew from before. This part we knew from before. This is the only new thing on this section 7.4. So how do I do that? Well, this number is not divisible by that. So I can't just leave the answer 5/3. So this is wrong. But I am going to break it, M5 into M3 times M2. And this is very important. I want you to pay attention right here, because somebody might be thinking, well, Professor, why can I not do like I did before, M4 times M1? Well, you cannot do that because this time the index is 3. And you need this number to be divisible by the index. This doesn't work. This does. So that's how I am going to break the expression. Okay, so you always have to break this value in such a way that one of the numbers, the highest number, is divisible by the index, which in this case is 3. So I have M3 cubic M2. There's nothing I can do here, but this one is identical to the N3. So this is M, and this stays the same. So now this goes over here. M times cubic M squared. And now you rearrange this for your final answer. So -2 goes first, M, N, and the radical with the index last. So this is inside, and this is inside. And this is your final answer for the problem. Okay, so this is how you simplify these equations. I'm sorry, these expressions. We'll see equations involving these later on, but ideally, we will see this type of problem or this type of problem more than these. These are just practice problems. You might see these on the exam as well. These are practice problems for 19.9 and 19.10. Okay, now in the event you have a multiplication, I will do one problem on multiplying radical expressions because it's the exact same process as you do this, but before you do anything, you will multiply these two into a single radical. So look what they're doing over here. Before we try to simplify them separately, we multiply them both inside the radical. And then once we have this, we have exactly the same procedure as we have over here. So I'm going to do one problem, and then you can do the rest for practice. This is already section 7.4, so we won't be addressing right here. But so let's do one, and I guess I can do, we already did fourth root, so maybe how about 1914, which is third root. Okay, so let's do that one, and then that will be the end of 7.3. So let's see, cubic root 3x squared y. So simplify again. Cubic root minus 3x squared y times cubic root. And for these problems, the index will have to be the same, 6xy squared. 6xy squared. So the very first step is you realize these two indices are the same. You are going to create a single radical, and you are going to put everything under the right. So here's your minus 18. X squared, x to the 1 is x cubed. Y to the 1, y squared is y cubed. Okay, so this is good. So this is where we are. From this point, I am back to that original problem where everything is under the radical, a number and two variables. So break it in the usual three parts. Here's my x cubed, and here is my y cubed. And it turns out that this problem, even though it was kind of scary at first, it's pretty straightforward because I know this is just x, right? 3 divided by 3, x to the 1. Same thing here, 3 divided by 3, y to the 1. And this is what we've seen before. I am going to break the 18 as, what is it? Think about it for a second. Right? Something to do with the 2 and a 9. Would that work? Did I copy these things right? Let's make sure. Minus 18. So we have to break it in such a way, something with the 2 and a, the only way I can do this is that way, right? Obviously 1 and 18 doesn't work. So I have to see if I can do that. So this doesn't help me, this doesn't help me, this does. So that's an 18. But because of the minus, I have to do 9 times minus 2. And then you might think, well, Professor, is the cubic root of 9 3? And it isn't. So this doesn't really work in any way possible, right? We can't get a number for this. So think about it. The only way I can break this is 1 times 18, that doesn't help. 6 times 3, that doesn't help. And 2 times 9, that's 18. But the cubic root of 9 is not 3, right? It would work if I had this. Cubic root of 8. Yes, this is 2. This doesn't work. Okay? So we have a real problem with this thing here. This doesn't really go anywhere. Well, what happens if it doesn't get simplified? What happens if I cannot simplify? Well, if you cannot simplify it, then it has to stay as is. But remember what I said before, do not ever leave the radical first. Your final answer would be this. It's really ugly. It's very possible they meant to write here 16. But if this was a 16, okay, then it would be negative 8 times 2. This is negative 2, and this is cubic of 2. Okay. And then this would perfectly work. It would be times negative 2 times radical cubic of 2. Rearrange negative 2xy cubic of 2. I think this is probably what they meant. They probably typed something wrong. And obviously on an exam, we wouldn't give you something this hard. We definitely want to give you something like that. So this is how you simplify these radical expressions. Just keep in mind that these problems are very important, but even more important than those are these right here, 19.9, 19.10. These are the types that should be prepared to answer mostly, but obviously these two are also similar problems. Okay. So in another video, I will continue with section 7.4.